Algebra 2, Chapter 9.2, Graphing Simple Rational Functions. Essential question. How are the graphs of a times quantity 1 over x minus h plus k and fx equals 1 over b times quantity x minus h plus k? And how are they related to the graph of fx equals 1 over x? Again, this h shifts the function, the parent function, left and right, and this other value here, k, shifts up and down. And I say shifts, and that's I guess that you could use that. But a more commonly used word than shifts is the word translates. Okay, so translates. Okay, and then translate, write down translates. So there we go. Okay, let's go on here. We will go to, and then the teaks here, or what changes, and so we'll go over these problems. I'm going to go some distance in here just to get a familiarity with what's going on. A rational function is a function of the form fx equals p of x over q of x, where p of x and q of x are polynomials. The most basic rational function with variable expression is the denominator is fx equals 1 over x. And this one here is, sometimes we call it the parent rational function. Okay. So next, state the domain of f equals 1 over x. The function accepts all real numbers except what? We cannot divide by 0 in math or in algebra because division by 0 is undefined. So the function's domain is as follows. As inequality x is less than 0 or x is greater than 0. In set notation, x such that x cannot equal 0. In interval notation, where the symbol u means union, so this is what this u does, union. And sometimes the pre-calculus students are the ones that first see that, but we have greater than negative infinity, less than 0, union, greater than 0, less than positive infinity. Okay, let's go on here. B, determine the end behavior of fx equals 1 over x. First, complete the tables. So we have the function where x increases without bound. And so this is going to be as x approaches infinity or positive infinity. And so we would say for this function here, we will get 1/100th. And in a decimal version, you can write this as 0.01. Or this next one for input of 1,000, we have 1 over 1,000, which in decimalized form is 0.001. And then we have 1 over 10,000, which in decimalized form is 0.0001. And then if we go to x decreases without bound and we plug in -100 for x, we get a similar looking thing except we have negatives. So -1/100th, -1/1000th, -1/10,000th, And then equivalently for decimalized version, we have 0.01, or actually negative 0.01, negative 0.001 for thousandths, and negative 0.0001 for 10 thousandths. So summarizing the results, as x approaches positive infinity, I hope you can see that we're getting closer and closer to 0. As x approaches negative infinity, f of x is increasing this time, but up towards 0. So either way, our end behavior is 0. And when you go ahead and graph this function, what does it look like? It looks like this. We are increasing, approaching 0. Decreasing, we're approaching 0 from the negative side. Okay, next. Be more precise about the end behavior of f(x) equals 1 over x and determine what this means for the graph of the function. So we saw in the previous pages f of x approaches positive infinity, f of x approaches 0. As x approaches negative infinity, f of x approaches 0. So the end behavior indicates the graph of f of x approaches but does not cross the x-axis or y-axis. And so that axis is an asymptote for the graph. And now what happens is that as x approaches 0, we're going to look at from the positive direction. And what that means is we're taking x value 1/100th away, and then 1/1000th away, and then 1/10,000th away. So we're getting closer and closer to the y-axis. And so what we get is, for the first one, 1 over 0.01 is going to be, for some reason I put negative 1 there, I don't know why, 1 over 0.01, and that's going to be equal to 100. And I'm going to show you that quickly. And then we have 1 over 0.001 is going to be equal to 1,000, and 1 over 0.0001 is equal to 10,000. And really, just looking at the calculator, that I don't know how intuitive it is for you, but I'm just going to do it anyway. So we put 1 over 0.0001. We should get 10,000. Yeah, we do. And so I hope you can see that as we get closer and closer to the y-axis, as this number for x, input value for x, gets smaller and smaller and approaches 0, we're going to be approaching infinity. And so down below, summarize the results. As x approaches 0 from the plus side, and that's what this one here is on the left, f of x approaches infinity. Okay, now on the negative side, as we approach from the left, we have at negative 0.01, we have negative 0.01 over, I wrote it wrong, didn't I? We're going to put 1 over negative 0.01. That's going to be equal to negative 100. And as we get even closer, we get 1 over negative 0.001. And that's going to be equal to negative 1,000. And then finally, we put 1 over negative 0.0001. We get 10,000. And so as x approaches 0 from the left, f of x approaches negative infinity. And if we look at the vertical asymptote, I'm going to kind of draw this here on the right. So you can see, I hope, that as we approach 0 from the right, we approach positive infinity. As we approach 0 from the left, we approach down to negative infinity. So this end behavior is something that we really will look at a lot more a couple years off in calculus, even more than in pre-calculus. So that would be a vertical asymptote. And here we have some graph f(x) equals 1 over x. First determine the sign on 2 parts of its domain. Well, we're going to go and use the negative values first. Negative values of x. We have f(x) equals 1 over x. So we have 1 over negative 2 equals negative 1/2. We have, then for input of negative 1, we have 1 over negative 1 equals negative 1. And finally, for 1 over negative 0.5, negative 0.5, there we go, we have negative 2. And so what that looks like on over here is if we go to negative 2, we get output of negative 1/2. We have an output of negative 1. We get an input of negative 1. We get an output of negative 1. If we have an input of negative 0.5, we get an output of negative 2. So what we're going to do is go like this. And it's hard to control that pen well enough here. It just isn't. Let's try that again one last time. Yeah, it's a little better. So that's what it's going to look like. And the right side of the y-axis, we have, if we put in 0.5, 1 over 0.5, we get 2. 1 over 1, we get 1. And 1 over 2, we get 1/2. So we have input of 0.5, output of 2, input of 1, output of 1, input of 1/2, output of 2. So from the right, we're looking like this. Okay, so we've drawn the graphs. Draw asymptotes as dashed lines. Okay, here's my dashed line. Dashed line in blue, hard to see. And then the horizontal asymptotes likewise. Okay, let's see. I really don't want to go any farther than this. The range is going to be similar to the domain. The function takes all real numbers except 0, so the function's range that it follows. And I'm not going to go any farther into this, and we'll get to the exercise next video I make here. I hope this has been helpful to you. This really shouldn't be too hard based on what we've been doing. Good luck, and thanks for viewing.